Throughout history, great societies that abused their land and treated soil like dirt experienced significant catastrophic results. The Dust Bowl in the 1930s is a classic example where extensive and resilient prairies of the U.S. Great Plains were uprooted and planted instead with monoculture crops and heavy tillage that loosened the soil and made it vulnerable to winds that swept this region. Now we risk repeating this story on a global scale due to ongoing intensive agriculture. In addition to soil degradation, a rapidly changing climate and a growing population further constrain our agricultural resources. And with soil loss also comes loss of an enormous amount of soil of carbon. Over the last 12,000 years, land use changes and poor management associated with growing crops and grazing livestock have caused the loss of 133 billion tons of carbon from the soils worldwide, amounting to about 13 years of global emissions at their current levels, and at least half of those losses have probably occurred in the last few centuries. While this may seem extremely alarming, let me tell you that this also presents a great opportunity to regenerate our soils. As a soil scientist, I'm interested in unlocking the secrets of soil and helping people understand how applying principles of regenerative agriculture, how they can help rebuild soils to enhance the health and resiliency of our agroecosystems and also help mitigate climate change. Much of my work has been in rangelands. 25% of our global land surface consists of rangelands. This is almost 70% of our agricultural land base. And importantly, 30% of our global soil carbon stocks exist in rangelands. While most soil health initiatives have focused on cropping systems, they failed to address the hundreds of millions of acres of degrading pastures and rangelands. And for decades, farmers and ranchers from around the world have adopted regenerative practices, and they have improved the overall health of their land. They're profitable, and they live happy and healthy lives. I've observed some of this in my own research. But to date, these observations have been largely anecdotal. So this has motivated many of my current studies, such as this study, in which we seek to quantify the social, economic, and ecological consequences of regenerative grazing management. In over 60 farms in Michigan, Oklahoma, and Wyoming, we are comparing conventional grazing management practices with adaptive management practices. These adaptive practices involve carefully controlling livestock density and how long a particular pasture is grazed at one time, mimicking the way bison used to roam our land, and emulating this grazer-grassland relationship that our ecosystems have evolved with. Others are using innovative practices such as adding compost, putting waste to work. There is growing evidence that compost can be used as amendments to soils and rangelands to enhance productivity and the soil health and serve as a long-term soil carbon sequestration strategy. We're in this study in western Colorado. We are adding compost to irrigated pastures and quantifying these effects to determine if this is actually a viable solution for ranchers in our own state. And in another project, we are working on building a low-cost, spatially resolved system, the Rangeland Carbon Tracking and Monitoring Tool. This ultimately will create a public-facing web application that can go into the hands of land managers so that to better enable them to understand the carbon balance of these extensively managed systems. And it will provide the tools that can be used for these managers to engage in the rapidly growing and evolving carbon markets. Rangelands are, of course, a critical component of our Colorado agriculture, but we also have a large diversity of cropping systems. And over the last couple of years, Together with the Colorado Department of Ag and hundreds of farmers and ranchers from around our state and other stakeholders, we have gained great momentum in building the statewide soil health program. These efforts have resulted in the passage of the soil health bill last year, in over $6 million in grant funding, which will provide resources to over 20 conservation districts at this point. It will provide the financial and technical assistance to producers to implement soil health practices, and it will provide the funding for research to quantify the effects and to build our statewide soil health inventory. This bottom-up grassroots movement sets a foundation to address farmer-centric programmatic needs and for making decisions, both policy and management, backed by robust science. Ultimately, my work as a soil scientist aligns with our mission that Dean Pritchett talked about as a land-grant university and many of our priorities in the College of Agriculture. By performing the research, advancing our scientific understanding, and building the tools to accelerate the implementation of regenerative practices, and ultimately bring soil to the forefront of solutions to climate change and sustainable and resilient agroecosystems. Thank you.